more topsoil. Would you? Taking a score for a long to go.
Yeah, John Hopkins initially asked me to come in and have a chat with him about soils at the very start of it. He'd heard my name mentioned a few times by various people on the design team and wanted to just find out whether we could help with the project and what we knew about soils and where we fitted into the landscape scheme. That was we initially got brought in beginning of 2009. I think probably the design had got to that stage where a lot of questions were being raised about soils, and the design team needed technical assistance to fill in some of the gaps, particularly on soil specification, tree pit design, land drainage, those sorts of issues which were cropping up time and time again. Yeah, so for the design stage, we undertook a fairly lengthy review over about 4 months, looking at all the elements within the design that had an impact on soils or would be influenced by soils. So that was the landscape design, the engineering design, the drainage strategy for the park, and also the remediation strategy. As it was a brownfield site, contamination was obviously a big issue, and they needed to understand how the remediation of the site would impact on the landscape and the planting within it. Yeah, we also got involved during the construction stage. For the design stage at stage F, we had another period of review work to do when the specifications for the landscape design came out. So we went through each specification in fine detail, just to make sure all the technical aspects were covered, and that also the specifications were practical, they could actually be achieved in reality. Because many times specifications are drawn up where in theory they work very well, but then it's impossible to actually find a soil which meets the specification, so that was an important part of the process. And then at the construction stage, we were given an 18-month monitoring contract by the ODA to oversee all elements of soils, from the initial importation of soils and the manufacture of soils, all the way through to the placement of soils and also checking the soils after planting. A lot of the problems with soils tend to be once the planting's all been done, and there's issues to do with compaction and poor drainage and limited root development. So we often get involved at that point to do what we call a soils health check, just to make sure everything's set up correctly and the plants have an opportunity to establish well. Yeah, the soils were really part of the main, part of the whole design process, the landscape design process, and it was really refreshing that they were considered at such an early stage. Again, in many projects, they seem to be the last thought. Usually the landscape design's all been finished before people think about what soil we're going to plant it into, but that wasn't the case on the Olympic Park. It was instrumental in many aspects. And really what we wanted the strategy to consider was all the different functions that soils have, and make sure those functions and the drivers within the park design were catered for. So for instance, clearly the soils had to be suitable for the broad range of plants and ecological habitats that were spread out within the park. A very ambitious range of plant species which we had to cater for. Then there was also the remediation strategy. The whole design of the park was based upon what's called a cover system, and the landscape soils were actually going to form what was referred to as the human health layer. So this was a layer of soil which was effectively squeaky clean in terms of contaminants, and was used in a means of encapsulating any remaining contamination under the site would be isolated from the end users and the site workers by the clean soils. So essentially the soil specifications for the park had to take that into account as well. The drainage strategy for the park was very interesting in that there was a minimum reliance on land drainage. Land drainage was really only put in at the low points adjacent to pathways, at the toe of slopes and areas like that. The soils would be expected to do a lot of the work without any artificial assistance. So we had to choose soils which would drain properly, as well as attenuate the water, because the whole sustainable urban drainage systems, the SUD systems, was very much a key part of the engineering design. So SUDS was a major part of the engineering and landscape design. So we wanted the soils to work efficiently within that system. So water attenuation and water filtration are a major function of all soils, be it topsoil or subsoil. And so again, we wanted the soils to fulfill that function without having to do excessive amounts of artificial management. Also, obviously, there was sustainability was a big part of it, biodiversity and sustainability. So the soil strategy took into account trying to minimise inputs of artificial fertilisers. We wanted to try and reuse recycled products as much as possible, things like green compost. And then in the future, for the legacy of the park, we wanted to make sure the soils would actually look after themselves as much as possible, rather than rely on high levels of maintenance to keep them going. One of the other major constraints of the park was the programme that had been set. Clearly the final deadline wasn't going to be moved, and the ODA wanted the park to have a year's worth of growth in it before the Olympics came along. So it was a very tight programme to actually go and find soils of the right quality and the right nature, bring them all in, and get them ready to receive the plants in advance. So we needed to find soils which needed the minimum amount of preparation and also would work efficiently from day one. Yeah, once we'd mapped out the soil strategy, we ended up with, I think, seven major soil types, subsoil being one of them, and then 6 different types of topsoil, which ranged from multi-purpose topsoil, which, as you can guess from the name, was designed for most of the trees, shrubs, ground cover plants, feature meadows, annual meadows, those sorts of things. And then we had more specialist soils like a high permeability turf soil, which was designed for the large spectator lawns. One of the design requirements was that we needed it to be compaction resistant, and also to absorb any rainwater that arrived during the games could be flushed away very quickly and taken into the soil. So it was effectively an engineered root zone that we used for the spectator lawns. And then we had much more specialist soils, such as urban tree soils for trees in paved areas, and then low fertility soils for the perennial meadow areas. Yeah, the soils cope very well, actually. Part of the mechanism within the soil composition was to be able to attenuate any surplus water that arrived. So we were very pleased after downpours. Once the soils were in and the vegetation was in, the soils coped very well with heavy inundation, and then they had good water holding capacities to deal with the drought, although certain areas were supplemented with irrigation, particularly during the first year. Yeah, in total, I think the figure came up to about 84,000 cubic metres of soil were used to construct the soils. Majority of that was actually subsoil. I think subsoil was around about 35,000 cubic metres. Multi-purpose topsoil was about 25,000, and low nutrient soil was about 15,000. So yeah, big volumes of soil were needed. Well, very often subsoil is the forgotten soil in a landscaping scheme. Everyone concentrates on topsoil, but we demonstrated on this particular project why subsoil was such an important element. It occupied at least 50% of every soil profile, and it was really there to provide the water attenuation that we required for the SUDS design, and also to attenuate the water and take it out of the topsoil to assist with the drainage design. I think, again, one of the main problems with landscape schemes in the past is that people have used too much topsoil and have placed topsoil too deep. We see schemes where a metre of topsoil is often placed in tree pits, and this becomes anaerobic and waterlogged. And we wanted to promote the use of subsoil, which is designed, nature's designed it to actually sit at that depth. So, yeah, the whole site was covered in a general purpose subsoil. Yeah, the soil strategy was very much site-wide. We had to pick up North Park, South Park and Eton Manor. And although each of those areas had different landscape habitats, more perennial meadows in the North Park and the London 2012 Gardens in the south, the strategy was capable of tailoring the soils for each one of those. So for example, the 2012 Gardens, there was localised amendment of the soils to suit the different plants from around the world, but the general strategy was the same throughout. At the design stage, the strategy was implemented through a series of detailed specifications that were drawn up by the landscape engineers, and we had input into the content of the specifications. So each specification, each soil type had its own specification, and they covered the testing parameters for the soils, the tolerances for each parameter. So for example, what range of pH each soil was allowed to have, and organic matter content, contaminants and so forth. And then each one set out what the sampling requirements were and testing requirements were for the contractor to go out and source the soil and continually supply the soil. Continual testing, sampling and testing is a very important part of it. Again, traditionally soils get tested at the beginning of a project, but that's as far as it goes. On this one we had continual testing for every 1,000 cubic metres that was delivered. The specifications also set out the mechanisms in which the soil should be managed, placed, handled on site to make sure that compaction was kept to a minimum, the right soil depths were achieved, and that the right preparation was done before planting. Yeah, I think most of the soils, well, all the topsoils were manufactured topsoils. There was no natural topsoil used on any of the park. It was all soils that had been blended from different components to create a topsoil substitute. And this whole approach to landscaping soils has been done on projects in the past, such as Terminal 5 Heathrow and others of a similar size. So I think the knowledge was already there, but we worked very closely with specialist soil suppliers to fine-tune the soils they were proposing to offer, to make sure they've met the specifications. So there was an element of testing and trial work, but I think the background knowledge was already there. We didn't do any on-site trials. We did various trials at the source locations where the soils would be made. That was the most obvious place to do it. There wasn't really room on site to do too many trials. Yeah, this is an interesting one. I have to say none of the site remediated soils were used for landscaping or for topsoil or subsoils. They either didn't have the right horticultural properties, or they were deemed to be still slightly contaminated, and therefore they couldn't be used as part of the final human health layer. So, but all the remediated soils were used, but they were used to form the landforms below the landscaping soils. So the wonderful slopes and various different structures you've got on the park, that's where the site soils were used, and then the imported soils or the landscaping soils were brought in after that to cap them off. Yeah, topsoil manufacture is really the concept of taking mineral and organic substrates, components, and blending them together at different ratios or specific ratios to achieve a topsoil substitute. What we're not doing is actually producing natural topsoil, but we're producing soils which will serve the function of topsoil once they're blended together and put into a landscape environment. So this is mainly done off-site at quarry locations, sand and gravel quarries predominantly, where the mineral fraction is found, and then that's combined with things like green compost and composted bark fines and wood fibre to add the organic element to the mixture. The moisture retentive soil was actually sourced from a sugar beet factory, where the sugar beet comes into the factory, it's washed off into lagoons and then dredged out and reformed back into topsoil. And this enabled us to source a soil with a very high clay content, which would function very well in the swales and wet woodland areas. The soils mainly came from quarries around the Greater London area. So I think there was Sussex, Essex and Suffolk and Hertfordshire were the locations of these in quarry locations. Yeah, actually in the quarries the material we use is not the valuable sand and gravel that's extracted for sand and gravel production. It's actually the overburden materials that generally sit above the sand and gravel that is used for topsoil manufacture. So from the quarry's perspective, this is a waste material or an unwanted material, but for topsoil manufacture purposes it's very valuable. It has a nice proportion of sand, silt and clay in it to make a nice soil when it's blended with organics. Yeah, most of the soil, traditionally soils are moved around the country by lorry, and at a very early stage the Olympics obviously had a policy to minimise lorry movements and try and use other forms of transportation to bring in materials. And in this particular instance, soils were brought in a lot by train rather than lorry. You could get about 1,500 cubic metres of soil on each train load. And initially the soil suppliers were very sceptical about the feasibility of doing it, because they would have to bring the soil from the quarry to a local railhead, load it on a train, bring it into London and then unload it again. But actually once they'd done it once or twice, they found that it was a very efficient way of doing it and the system worked very well. And I think this is probably something that could be thought of for the future. Yeah, during the construction of the project, we had an on-site presence throughout the period. This involved all elements associated with the importation and selection of soils at source, right through to their placement on the scheme. So we went to each source, inspected it, made sure the right quality control measures were in place. We reviewed all the test data. The contractors were responsible for getting the soils tested against the specifications. We then reviewed that data and made decisions on whether any non-compliances that were found would be considered significant and therefore the soil was rejected, or whether some elements could be accepted without affecting the overall quality and function of the soils. We also oversaw the importation and placement of the soil, which is a critical part, and then went on to look at the cultivation of soils, making sure the right soil depths were in place, the tree pits were backfilled with the correct materials, and finally, yeah, just checking that the soils were fit for purpose at the end of the project. I think generally I'm pretty pleased with the outcome. The whole project was looked after by all parties. Everybody invested a lot of time and effort into it, and I think we're reaping the rewards of that now. Probably the only thing I would say that there's localised areas of compaction, purely because of the timescales required to install this landscape scheme meant that there was a lot of activities overlapping on each other, and invariably some compaction was left in. But I think we now have an opportunity post-Olympics and during Legacy to deal with those localised areas and sort them out. Yeah, I think as a whole, manufactured topsoil, this whole concept of taking unwanted recycled materials, blending them together and to form long-term sustainable growing media is a fantastic story. It's something that I've been working on probably for the last 15 years, and it's been used in anger increasingly over the last 5 or 6 years. But I think the Olympic Park is probably the piece to resistance for that. We had so many different soil types to create, and the same approach was applied for each one, although the materials used and the quantities of each were very variable. So I'm really pleased with the way manufactured soils have worked on the scheme. I mean, to put it in a point, it would have been completely unfeasible, impossible to source natural topsoil and natural subsoil in the quantities we required, and the timescales we required them in, which wouldn't have been possible to source natural soils. We had to use some sort of process, a manufacturing process, to create the soils. I think also, again, because of time constraints and various contractors working in close association with each other, we had to come up with tillage equipment, cultivation equipment, which could be worked not only in the big open areas but also in the small discrete areas. So various attachments were, we recommended various attachments be used that could be put, a bucket could be taken off an excavator and replaced with different tillage equipment, a tine or a landscape rake. And many of the contractors hadn't seen these before until we recommended them. But after using this equipment, they swore blindly they would never do a scheme without them. So again, I think we introduced new ideas and new equipment into the process as well. I suppose for me personally, I've been doing landscaping soils for about 20 years, and every project has certain challenges and certain requirements. But I think the Olympic Park project, because of its vastness and the range of habitats and the delivery requirements and so on, it meant that I think probably all the various elements of knowledge I have from different applications of soil science were certainly tested on this project. I thoroughly enjoyed the whole process, both the design work and the implementation. It was fascinating actually being part of the construction process. And certainly that'll be a lifelong memory for me. I think from a soil scientist perspective, what we want to be able to see in 5 years' time is that not only the soils but the flora and fauna that rely on the soils are thriving, and that they are very much deemed to be long-term sustainable habitats and ecosystems. We strive to make the soil sustainable, not only in terms of using recycled materials, but also sustainable in terms of looking after themselves. That's the main goal of manufacturing topsoils. So I'd like to come back in 5 years' time and see that obviously all the plants are put on growth and established well and are healthy, and also that the birds and invertebrates and other wildlife are actually able to establish and use the park as was designed. Cover systems are widely used for brownfield site remediation. Effectively, a cover system is a layer of clean soil which encapsulates potentially contaminated ground underneath. So it's widely used for housing schemes now, where back gardens and front gardens have usually about a 600 ml layer of clean soil placed over the top. So it's widely recognised as a main form of contaminated land remediation. So for the Olympic Park, it was again a perfectly acceptable system to use, and so again the imported topsoils had to not only be fit for purpose in terms of landscaping, but also had to be clean to meet the remediation standards of the park. No, there was no need for a capping layer or a clay capping layer. Effectively, the human health layer was a capping layer. It was creating a sufficient depth of clean soil to isolate any contamination from underneath. Yeah, the site soils generally had varying forms of contaminants within them, even after remediation. The levels weren't sufficiently clean enough to allow them to be used within the human health layer. They're absolutely fine to be used underneath the human health layer. Things like asbestos, heavy metals, hydrocarbons, chemical contaminants were still present, and also there was instances where, although the soils were clean chemically, they had physical contaminants such as glass, nails, other forms of sharps, which meant you couldn't use that soil on the surface. Even if some of the soils were then found to be physically okay, they then had the horticultural properties were limiting, such as the pH levels, salt levels, and so on, which inhibited their use for landscaping. I think soil should be thought about at the start of any project. Thankfully on this project we were involved very, very early on, and we were able to make a difference in terms of input into the overall design by getting the soils right. So that would be probably the biggest lesson to learn. But I think following on from that, also bearing in mind that soils aren't there just to grow plants, they're also there to attenuate water, be part of the remediation process, provide ecological habitats for the wider environment, and they play a key role in the sustainability of landscape construction. It's a very small industry in many respects, and I'm very lucky that I've carved out a niche role dealing with soils within the landscape industry. And so I think once you've worked with certain people on projects, there's a tendency for your name to carry forward onto new projects. With the Olympic Park, a lot of people had been involved with Terminal 5 Heathrow, which was the predecessor in terms of a very large landscaping and construction project. And a lot of people from the T5 project ended up working at the park. So there was a lot of friendly faces and familiar names when we did start working there. So yeah, very much I think networking is a really important part of career development and company development. We all end up. I always say that don't ever burn any bridges, because you might regret it in the future. So yeah, work hard on every project, so you set yourself up for hopefully the next one. Setting up their own practice. I think yeah, work hard, work really hard at it. Make sure you've got a business that has a good service. If you don't get involved with services or projects that you're not comfortable with, always work within your capabilities. But for any small business particularly, you've got to work hard, and you've got to not only concentrate on the technical aspects but also the commercial aspects of a business. Speaking to people, letting people know you're out there, but also getting the sums right when it comes to quoting and working on projects. We did work closely with the landscape architects. I think there was a lot of different disciplines involved by the time we were brought into the project. So you had landscape architects and environmental consultants and civil engineers, all who'd brought their elements of the design to quite a high level of detail. So we did feel as if we were playing catch up to some extent, but also we were there early enough, thankfully, to be able to modify a few things, change a few things, and hopefully for the better. We had a little bit of input into the drainage design to make it more efficient. We certainly looked at the tree pit design quite closely and fed into that. Although we didn't interfere with species selection and so on, we have a lot of experience in getting the soils within tree pits to work properly and work well, both in hard and soft landscaping environments. As a soil scientist, you have to speak different languages. The language of a landscape architect is different from that of an engineer or an environmental consultant. But I would say generally, because we're championing the quality and the function of the soil for landscaping purposes, we do tend to end up siding on the side of the landscape architect and looking after their interests. I think generally they, in many projects, not necessarily the Olympics, but many projects, landscape architects often have to fall in line with what the engineers want. And I think the park in particular was an occasion where all parties had equal input and equal value to put into the design. Landscape architects are very often the poor cousins of the scheme. You know, they're sort of I mean, obviously with a park project, they are much more dominant than a major construction project, a building construction project. But as our role looks after their interests, we very much have to fight their corner when it comes to the soil elements. The main focus is on getting the soils clean, which is obviously very important, but also making sure that they stand up correctly and don't slump or collapse. But the icing on the cake bit, where we want the soils to be light and fluffy and absorb water and breathe and have lots of bugs in them, often gets overlooked in big civil engineering projects. And so we were insistent on making sure that the soils in that top 800 mil were going to look after the plants, attenuate the water and so on.